Everyone, I am Karthik, Assistant Professor of Mathematics, SNS College of Engineering. In this lecture video, I will explain about double integration. Okay, what is double integration? Double integration is a mathematical operation used to find the volume, area, and other quantities under two-dimensional function only. It involves integrating a function over a region in a two-dimensional space. Understanding the limits of integration. For a double integral over a rectangular region in the xy plane, the limits of integration are typically expressed as double integral f of x comma y dA, where A represents the region of integration. The limits of integration for x and y are determined by the boundaries of the region. For example, if the region A is defined by 0 less than or equal to x less than or equal to A and 0 less than or equal to y less than or equal to b, then the limits of integration for x would be 0 to a and y from 0 to b. If the region is more complex, for example a triangle or a circle, the limits of integration need to be adjusted accordingly to cover the entire region. Techniques for evaluating double integrals. There are several techniques for evaluating double integrals. First one, iterated integration. This involves breaking down the double integral into two separate single integrals, one for each variable. You integrate first with respect to one variable while treating the other variable as a constant. Second one, change of variables. It is beneficial to change variables to simplify the integral. Common transformations include polar coordinates for circular or radical symmetry or other coordinates transformations to simplify the region of integration. Third one, integration by parts. If the integrand is product of two functions, the integration by parts may be applicable. Use of symmetry. Exploiting symmetry can simplify the integrand or the region of integration. Special functions. In these type of functions, trigonometric functions or exponential functions using identities or properties specific to those functions can simplify the integration. Numerical methods. When analytical methods are impractical, numerical such as integration or numerical quadrature can be used to approximate the integral. Double integrals in physics and engineering. In physics and engineering, double integrals often represent physical quantities like mass, density, electric charge, or fluid flow. Applications of double integration in mathematics. Find area and volume. Double integration is commonly used to find the area of regions bounded by the curves in the plane and the volume of solids and surfaces in three-dimensional spaces. Probability and statistics. In probability theory, double integration is used to calculate the joint probabilities and expected values for continuous random variables. It is also employed in statistics for computing multivariate probability. Vector calculus. In vector calculus, double integration arises a context or line or surface integrals. For example, in electromagnetic theory, double integration is used to calculate the electric and magnetic flux through surfaces. Differential equations. Double integration is used to solving partial differential equations, particularly in problem involving boundary value problems and as well as initial value problems. Heat and mass transfer. In engineering applications, double integration is employed to analyze heat transfer and mass transfer phenomena. Fluid dynamics. Double integration is used to compute properties of fluid flow such as fluid velocity, pressure, distribution, and rate of flow. In mechanics, double integration is utilized to determine the mass, moments in area, and other properties. Solving area and volume problems by using double integration. Define the region. We define the region in the plane or space over which you want to find the area or volume. Set up the integral. For area problems, you will set up a double integral with the integrand being 1 and representing the area element dE. For volume problems, the integrand will be the function representing the height or depth of the solid. Determine the limits of integration. The limits of integration for both variables x and y x and y for area problems and xyz for volume problems. Evaluate the integral. Compute the double integral using techniques such as iterated integration, change of variables. Tips and tricks for mastering the double integration. Understanding the geometry. Visualize the region of integration and understand its geometric properties. Next, practice and iterated integration. Break down the double integral into two single integrals and practice iterated integration. Explore differential techniques. Use symmetry. Work in real world applications. Practice solving real world problems that involve double integration, such as finding areas, volumes, and probabilities. Thank you.